to find the determinant, we will, now the determinant, not only does it say find the determinant, but you'll notice that these are the absolute values. Okay, so in the context of a matrix, we know that it's a determinant that they're looking for. That right there is negative 5 times negative 1 minus 0 times 3, which would give us positive 5. All right. Now this just tells us that if the determinant is not 0, then this guy does have an inverse. Okay, so a determinant is important, not only for just whether or not you're ready to solve for a system or a matrix equation, but it's got lots of uses farther down the road with like things like vectors and stuff like that. Okay, so just enjoy it. It's easy. Find a determinant, no biggie. 3 times 1 minus negative 4 times 4. That will be 3 plus 16, so that is going to be 19. All right, now the determinant for this guy is going to be a little different. We've got to add, now you got to be careful with these, okay, and these will be done by hand, okay. We rewrite these columns, but only do the first 4 rows, okay. All right, and then we multiply those guys, so that equals negative 8 plus negative 15 plus 0 minus the diagonals going this way, which is, that's 4 times positive, that's going to be 12. This is going to be 0, and that's going to be 0. So we've got negative 23. I made the mistake here of putting a negative 8 instead of 0. So that should be a 0 plus negative 15. So that should be negative 15, and then that will give us our negative 27. That's our final answer. We're going to go ahead and add these rows here. Going to use this space here. The diagonals going, let's see, move this up. Okay, so I am terrible making dumb mistakes with this. So negative 2, positive 16, 16 times 5 is 80. That's going to be a negative 80. Then I'm going to get positive, 6. Bam. Then I got to do that. That's going to be negative 12, and then that's going to be 4. That's negative 20. Okay, and then I got one more. That's positive 4. All right, so that's going to be negative 82, 6. That's going to be a negative 74, right? 6. And then that's going to be plus, that's going to be a negative 32 plus 4 is 20, and negative 28. So then 76 minus 28 is negative 48. Okay? Negative 48. And does he win the grand prize? I do. I'm good at this stuff. Yay. All right, find the inverse of a 2 by 2. If it's anything larger than a 2 by 2, you go to the calculator. All right, so what you need for an inverse is just kind of an interesting kind of switch around that we, you know, when you're in college, you've got to prove this, but in high school, it's just good to know that, okay, that's what an inverse is. All right, I'm ready to do some hardcore stuff when you get to college. You want to do a 1 over the determinant of this guy. So that's negative 7 minus a negative 12. That's actually going to give you 5. So that'd be 1 over 5 times these guys moved around. So the 1 goes here, negative 7 goes here, and then you switch the signs of the B and the C. Okay? So then you can leave it like this, or you could just put them all over 5. Okay, sometimes they cancel, or sometimes they reduce, sometimes they don't. Okay? All right, and that's all. Now, what are you using the inverse for? You're going to use the inverse for this stuff. Now, this is definitely going to be in a calculator. I'll just let you look at the, to find the inverse, okay, you're just going to go to second matrix, move over to math, and in math, right there is DET. That is the determinant. Go ahead and then go get the matrix that you just typed in for either A, B, C, D, E, whatever you did, okay? All right, I don't know. It looks like there's a 3 by 4 in there. Let's see what happens. Oh, yeah, because you can only get the determinant of a square matrix. Okay, so you can't do that. All right, next, solve each equation here. Let's see. What I'm going to do is, well, this one, I'm going to get away with not having to use the calculator here because what I'm doing now is just moving a collection. It's almost like I'm doing 4 one-step equations at once, okay, which is kind of cool when you think about it. But you're basically juggling 4 numbers. You're moving them all to the other side with addition, okay? So 1 plus, that would be plus 3 though, because we're subtracting. So that would be 3, okay? That would be negative 8. This is going to be 10. And then that's going to be positive 2. All right, you didn't need a calculator for that. Now we'll swing all these guys over here and divide by 3. Okay, so these guys will all become subtracted, and then we would take each one of those and divide by 3. Now you can divide a matrix by a scalar of 3, but you cannot divide by a matrix. Okay, but you can divide by a scalar, which is like a factor of 3. All right. Now this one is going to require an inverse. So what we would do is we would say, I don't know, call that A. Okay. So y would equal the inverse of this guy. And what I'll do is instead of calculating the inverse, I will just put a negative 1 in front, and then I will multiply it to this guy. Okay. And I'm not even going to do that. I'll just let you look at the answer key, but that's how we would do it. All right, now with this one, we've just got more of this. Watch out if there's no unique solutions, because if we do get a determinant that is 0, then it won't work, okay? So let's see, that determinant is okay. This is the guy we need to take an inverse of. This is the guy we need to take an inverse of, because you can see that it's attached by multiplication. This guy's good. I'll just subtract him. Okay, so he would be subtracted from both sides. You get that. Okay. Then you would take the inverse of whatever this guy, we'll call him A, and we'll call this guy B. Okay, and it's just better to write it like that. Okay. All right. You're going to do the same thing here. We're going to add this guy to both sides. Okay. And then we would call this guy A. We're not going to call him B though. We'll call him C. And then B would equal A inverse times C. Okay? And again, refer to the answer. The answer key. Okay? All right. This guy, he is the one that you can subtract. Okay, from here. Notice that you can subtract it. Okay? Because this is a 2 by 1, you can only subtract a 2 by 1. If the dimensions would have been any different, okay, if that would have just been a negative 2, then this would have been indeterminate. Okay, you can't do it. Okay, there's something wrong. Okay. All right, so let's call this guy A. We'll call this guy B. So C equals A inverse times B. Now, one of the things you might notice, now as I was doing this, I was actually calculating the determinant in my head to see if the determinant was 0. In all 3 of these cases, the determinant was not 0. You can see this is negative 9 minus a negative 8. That's 1. Okay, so that means he has an inverse. So you're going to get answers in your calculator, but as soon as we get to here, this is the issue. You're going to go ahead and just, doing your business. Okay, you're going to subtract those two. yada, yada, yada. But what you'll notice, though, is that this multiplied to itself is 10 minus 10 is 0. So what would happen is that if you went to type this into your calculator, you would find that it would say like no solution or no unique solution. It's because A does not have an inverse, which means there is no solution. Okay? And even better, it's no unique solution. Okay? All right. All right, and then these guys also are just row reduced echelon form. You guys can look at the answer for these. Did I put these on another sheet? I wonder why 62. I don't see the answers to 62 here, so you guys actually need the answers. Nope, that's the wrong one. Shoot, just a second. Oh, there they are. 62 is D, and 63 is D. Okay, so it is there. All right. And if you guys have any questions this morning or tomorrow morning, depending on when you